this function f of x is equals to x cubed plus 2x plus 1, and then the values of x is 1, 2, 3, 4, 5. Okay, so what we're going to do first, we're going to draw a table like when we are drawing a graph. Okay, so on our table we're going to have the x values and the y values. Y equals to f of x. Okay, so this is how our table is gonna look. So we have 1, 2, 3, 4, 5. These are the values of x that we were given on our example. Okay, from here. So we have the function x cubed plus 2x plus 1, and then we have the values of x 1, 2, 3, 4, 5. So here I was writing the values of x. So to get the values of y, we have our function as x cubed plus 2x plus 1. Okay, so to get the values of y, we're going to substitute the value of x into our equation. So it's going to be 1 cube plus 2 into 1 plus 1. Do you get, guys? Do you get it? So we're going to substitute 1 into our function. So 1 to the power of 3 plus 2 into 1 plus 1 is going to give us 4. Okay, and then when we substitute 2 here, it's going to give us 13, and then when you substitute 3 in this our function, it's gonna give us 34. Okay, and then when we substitute 4, it's gonna be 73, and then when you substitute 5, it's gonna be 136. Okay, so when we construct a table, we start by drawing this table and then substitute whatever that we have. We have x values, and then we're going to calculate y values. So to calculate y values, you just substitute the x values into your function. Okay, now moving forward to construct. Remember here we want to construct a table. Okay, so what we're going to do now, we're going to write the value of x, the value of y. Okay, remember I said for forward, where is it? For forward, we write it like this, and then for backward, it faces down. Forward, it faces up. Backward, it faces down. Okay, so now we're gonna start with the forward one. So we're gonna have change in f. Okay, and then change in f squared f, change in cube f, change into the power 4f. Okay, so now this is how our table is gonna look like. Okay, so remember we have the values of x and y, right, from our table. The x is 1, 2, 3, 4, 5, and the y is 4, 13, 34, 73, and 136. Okay, so we're just gonna write our values here. So we have 1, we have 2, we have 3, we have 4, and we have 5. Let me just write it here. And then we have 5. So let's say this is our paper. I think I should just use the number line. Let me just cancel this one. Sorry. Let me use this paper. Okay. So here we had x, we had y, we had change in f, we had change square f, change cube f. Okay, and then change the power 4f. This is change to the power 4. Okay, and then we say under x we have 1, 2, 3, 4, and 5. Okay, and then y we calculate, we get 4, 13, 34, 73, 136. So these are the values that we calculated from our function, right? Guys, are you following?
Yeah.
Okay, so now we want to construct a table, to construct a finite difference table. So what we're going to do here, to get the value of change in f, okay, we're going to say Where's my calculator? You're going to say 13 minus 4, which is 9. So it's this one, 13 minus 4, and then we're gonna get 9, that value, that answer, we write it here, okay? And then the second one, with all the time, guys, we skip a line when we construct a table, okay? So at the end, we want our table to form a pyramid, okay? It's gonna form a pyramid shape or a triangle shape here, okay? So it's gonna be like this, okay? So that's why we're skipping a line, okay? So we have 9. 9 is coming from 13 minus 4, okay? And then now the second answer is going to be 34 minus 13. 34 minus 13 is going to be 21, okay? And then 73 minus 34 is going to be how much? It's going to be 39, okay? And then 136 minus 73 is going to be how much? 63. Are you following, guys?
Yes, we are.
Okay. And then now when it comes to the second change in f squared, we're going to continue again doing the same. So it's going to be 21 minus 9. 21 minus 9 is going to be 12, okay? And then 39 minus 21 is going to be 18. So all the time we skip a line, we skip a line, we skip a line. Remember, we want our table to form a pyramid, okay? And then now 63 minus 39 is going to be 24, okay? And then we continue. The third one is going to be 18 minus 12. 18 minus 12, which is 6. And then 24 minus 18, it's 6, okay? And then the fourth one is going to be 6 minus 6, which is 0. So guys, we stop when we have one value, okay? So if here on the fourth one we have two values, we're going to have the change to the power 5f. And then we continue to subtract, okay? As you can see, it formed a pyramid like this. It formed a pyramid, a triangle. That's why I was giving a line. So all the time when you construct a table, it has to form a pyramid, okay? So this is a forward different example, okay? A forward different example. Okay, so now we have this table. This is how we construct a table. So we're going to be given the x values. We're also going to given a function, and then we substitute the x values into our function. We get the y values. After getting y values, we're going to subtract the second value, the y2 minus y1, y3 minus y2, y4 minus y3, y5 minus y4, so, okay, up until we get one value at the end, okay? Do you have any question here? Okay.
So, la able square root
or the changing square f.
We don't use them.
No, not really. We don't use them. Here it's just showing that is the first one, this is the second, third, fourth. So, okay? Yeah, okay. So these values, let me just circle them. These values, the one that I'm circling, these are a coefficient of forward difference, ne? The one that I'm circling, it's what? It's for forward, okay? It's for forward. It's the coefficient of what? Coefficient of forward difference. It's what? Finite, a forward difference here. It's a forward difference, the circle one. And then the one that I'm gonna circle with a different color here, this one are the backward, okay? The green one are coefficient of what? Of backward difference. Remember, we have forward, backward, and divided. So the forward one are the yellow ones, okay? And then the back one are the green ones, okay? So these are the coefficients of backward difference and forward difference, okay? The top one is for forward, and the bottom one is for backward, okay? And then this is how we construct a finite difference scheme. This is how we construct a table, okay? Okay, so the circled one with yellow is for forward, is the coefficient of forward difference, and then the green one are coefficient of backward. Okay, sharp. So here we do you have a question? Okay, no. So we have formula for forward and backward and divided. Okay, so now let's continue, and then let me write the formula for backward, what do you call the forward difference formula. So the forward difference formula, it's like this. So we have the P of X. P is for polynomial, okay, equals to Y0 plus P change in F. This is for forward. Remember I said for forward change in F, it faces up, okay, over 1 factorial, okay. Guys, you have to cram this formula. I don't think they do bring it on your formula sheet. You have to know it, if I'm not mistaken. Okay, plus P into P minus 1 change square F. So this is the formula for forward difference. 2 factorial, okay, plus P into P minus 1, P minus 2, change to the power of 3F over 3 factorial, okay. This is factorial, plus, let's say we have up to 5, okay, up to 5. So if you want to write the number 4, it's just gonna be the P into P minus 1, P minus 2, and then P minus 3, and then change to the power of 4. Okay, so it's gonna depend where your table ends. So our table ends at change to the power of 4, which means your formula is also gonna end at what? At change to the power of 4, okay, over 4 factorial, like this. So this formula is there on the textbook. It's there on the textbook, okay. So y0 is the first value of y, okay, first value of y. So y0, our y0 here is gonna be what? It's gonna be 4, okay. Our y0 is gonna be 4. This is our y0, it's gonna be 4, okay. And then P, this value, remember this one is for polynomial, and then this P here on the formula is equals to x minus x0 over h, okay. x0 is gonna be the first value of x, which is what? Which is 1, okay. The x0, this is our x0, this is our y0. Our x0 is 1, our y0 is 4, okay. Then moving forward, as you can see here under P, this P is we're gonna use this formula, we substitute here into our formula. So P is equals to x minus x0 over h, okay. So h is a step size, we call it step size, okay. So it's a step size. So the formula for h, let me go forward, h equals to b minus a over n minus 1, okay. So b is the last value of x, okay, and then a is the first value of x. Remember our x values, it was 1, 2, 3, 4, 5. So which means b is gonna be 5, and then a is gonna be 1, okay. And then n we just count how many x values do we have. 1, 2, 3, 4, 5. So our n is gonna be 5. Do you have any question here? Hello?
No, I don't have a question. You saying that this this formula, we have to cram it. Or we have to know it.
You have to know this formula. Last time when I checked, he was not providing it on the formula sheet. So you have to know this formula for forward, backward, and divided. So this is the forward difference formula. So it's px equals to y0, p change in f over 1 factorial, plus p into p minus 1 change square f over 2 factorial, plus p into minus 1, p minus 2, change to the power of 3 f over 3 factorial. So this formula is going to depend where did you stop on your table. Okay, so on our table, we stop at change to the power 4. If we stop at change to the power 5, you were going to write up until 5.
Okay.
Yes. Okay, so this is the formula for h. For y, y0 is the first value of y, and then p, this is the p's here in these formulas, and then p is equals to x minus x0 over h. x0, it's 1, okay? H, we call it step size, and then we calculate it as b minus a over n minus 1, and then b is the last value of x, a is the first value of x, and then n, we count values of x. How many values of x do we have? Okay, so here we count number of x. How many do we have? Okay, moving forward, let's make an example. Let's do activity 2.1 with forward formula. Okay, I don't know if you guys opened the textbook. Did you open your textbook?
Yes, perfect.
Okay, so we're gonna do example for forward difference, activity 2.1, number 2. Okay. Let me also open it. So activity 2.1, it says number 2, okay, determine the forward difference interpolation polynomial for the data in the table and then estimate f prime of 6. So we're going to use this number one table, okay, which is x is equals to 1 0 2 3, f of x 2 7 8 6. So number 2, we're going to determine the forward difference interpolation polynomial for the data in the table, then estimate f prime of 6. So we have a table already. They've already given us the table, which is we have x, let me not write the cost. So we have x 1 0 2 3, and then we also have y, which is 2 7 8 6. Okay, so this is what we're going to use. So I want you guys to construct a table, and then you're gonna tell me the answers. Okay, so we have this table, and then I want you guys to construct a table. Remember, here they want us to what? To determine a forward difference interpolation. So to determine that, you start by constructing a table, and then you're gonna write your formula, and then you substitute your values. After that, we're gonna calculate the f prime of 6. Okay, so let's construct a table, and then you guys are gonna tell me, or okay, what to write here. We're gonna have y and x. So we already have the y and x value. So it's 1 0 2 3. Okay, and then y we have 2 7 8 6. So I want you guys to give me the answers. What should I write under change in f? And remember, when we construct a table, we skip a line. So we're gonna write our answer here on the empty line. Okay, so yeah, so can you please give me the answers for change in f, the first change in f?
The first one is going to be 5. 7 minus 2.
Yes, it's gonna be 5. And then the second one, Rochi?
It's gonna be 1.
Okay, the last one is gonna be minus 2. Okay, and then the second one is gonna be, remember, we calculate up until we have one value.
1 b.
Yeah, and then change in square f was the answer?
4.
Minus 4. 1 minus 5 is gonna be minus 4.
Yeah.
Minus 2 minus 1 is gonna be minus 3. Yeah.
Minus 3.
And then we're gonna have change in cube f. Okay, and then here it's gonna be minus 3 minus 4, which is gonna be what? Which is gonna be 1. Okay, and remember we said what do you call forward difference? We use, this is our coefficient, the top one are our coefficient, and then for forward, and the backward is the bottom one. Okay, so now we are done constructing a table, and then they want us to estimate, let me see, they want us to determine the f prime of 6. Okay, they want us to estimate f prime of 6. Okay, we are looking for that. And remember here we have the formula. Remember formula, it's p into x equals to y0 plus, it's gonna be plus what? P, change in f, over 1 factorial, and then plus p into, let me write it down this side. So we are looking for f prime of 6. But what we're going to do first, we are going to write our equation, and then we calculate the f prime of 6. Okay, so moving forward, let me just write the equation. So it's going to be p into x equals to y0 plus p, change in f, over 1 factorial, okay, plus p into p minus 1, change square f, over 2 factorial. Okay, plus, remember our table, we stopped where did we stop? I think we stopped at change in, we stopped at changing 3 to the, change to the power of 3f. So we're gonna stop then. Plus p into p minus 1, p minus 2, change to the power of 3f, over 3 factorial. So this is where we're gonna stop, because our table end at change to the power of 3f. Okay, so remember I said p is equals to x minus x0 over n minus 1. Okay, and then no, over h. Over h. Okay, so we're gonna calculate p. Okay, and then h is equals to b minus a over n, right? So to calculate p, we have to start by calculating h first, and then n, remember n, we count all the values of x that we have. So how many values do we have under x? 1, 2, 3, 4. So which means our n equals to 4. And then now let's calculate h. So b is the last value of x, and then yes, and then a is the first value of x. So it's gonna be 3 minus 1. Okay, 3 minus 1. So it's gonna be 3 minus 1 over n. Our n is 4 minus 1. So this is our formula for calculating h. Okay, h is equals to b minus a over n minus 1. So which means our h is gonna be equals to 3 minus 1 is 2, 4 minus 1 is 3. So it's gonna be 2 over 3, which we can write it in a decimal place. So it's gonna be 0.67. okay, like this. And then now we can substitute back and get the value of p. Okay, so p is equal to x minus x0 over h. And remember here, f prime of, they say we have to estimate this, estimate f prime of 6. So the 6 here is x value, because is this f prime 6 is the same as f prime of x. So which means x is equal to what? Is equal to 6. Do you get it?
Yeah.
Okay.
Yeah.
So now we have the value of x. We also have the value of x0. X0 is what? It's 1. Okay, so we're going to say our p, it's 6. 6 minus 1 over h. H is 0.67. And therefore, p equals to 7.46. Okay, so we have the value of p. We also have the value of h, and then value of n. So now we can just substitute back to our equation. Our y0 is what? It's 2. Okay, our y0 is gonna be 2. Now let's substitute to our equation. Let me write it down this side. So this was our equation. I'm just gonna rewrite it. P, changing f, 1 factorial plus p into p minus 1, change square f, plus p minus 1, and then p minus 2. Here is changing to the power of 3f. Here we have 2 factorial, here we have 3 factorial. So now we're going to substitute. We have p into x equals to our y0. Our y0 is 6. It's 2. Sorry guys, it's 2. So we have 2 plus our p. P is 7.46. Okay, so it's going to be 7.46. Okay, and now here we have what? Changing f over 1 factorial. Okay, plus, remember they want us to estimate f prime of 6. Okay, plus p it's going to be 7.46 into 7.46 minus 1, and then change square f over 2 factorial. Okay, plus 7.46 into 7.46 minus 1, and then 7.46 minus 2, change the power of 3 f over 3 factorial. Okay, so we're going to have this, and then we're going to calculate. So moving forward, so before moving forward, do you get it? So here we were just substituting the value of p wherever there's p. Okay,
Yeah.
and then we have changing f, changing square f, changing cube f. Remember the changing f is these values. It's this one, the one that I circle, the forward one. Remember we're doing forward difference. So we have 5 minus 4, 1. Okay, so here we substituted our values, and then let's continue. We're gonna calculate this. The 7.46 over 1 factorial term is changing f. So we're going to have the p of x equals to 2 plus, and then we calculate this. 7.46 divided by 1 factorial term is changing f. So here we haven't substituted the values yet. So it's going to be 7.46 over 1 factorial time is this. So it's going to be 7.46 times 1 over 1 factorial, which is 7.46. So it's going to be plus 7.46 changing f. Okay, plus, and then we're going to calculate this. 7.46 into 7.46 minus 1 over 2 factorial is going to give us 24.096. Okay, so it's going to be plus 24.096 change square f. Okay, and then plus, we're going to do the last one. So the last one is going to be 7.46 into 7.46 minus 1 times 7.46 minus 2 over 3 factorial. And then we're going to get it as 43.854. 43.854. Okay. So it's going to be 43.854. And then change to the power of 3f. Okay, remember now they want us to estimate this value. Okay, they want us to estimate f prime of 6. And then here we have p into x, and then we have change in f. So from here, we're going to let our change in f be equals to x. Okay, so that we can derivate. Remember, this sign is for derivating. Okay, we are going to derivate, and then we're gonna let change square f equals to x squared. Okay, and then we're also gonna let change cube f equals to x cube. Okay, the reason why we are changing, I just want us to derivate. Okay, I just want us to derivate with respect to x. Okay, so we're just gonna let change in f equals to x, and then change in square f equals to x squared, and then change in f cube. Change in cube f equals to x cube. So wherever there's change in f, we're gonna put x, and then wherever there's change in square f, we're gonna put x squared, and then wherever there's this, we're gonna put x cube. Are you following?
Yes, we are. It's long, this thing.
Yeah, it's very long. It is very long. And remember, we're still on that quotient. Okay, so moving forward, we're gonna have the p of x equals to 2 plus 7.46. Remember, we said we're gonna write it as x plus 24.096 x squared plus 43.854 x cube. Okay, remember we want f prime of 6. So to get f prime of 6, we have to derivate. We have to derivate this. So it's gonna be p prime of x equals to derivative of 0 is 0, and then derivative of 7.46 is gonna be 7.46 plus derivative of 24 times x squared is gonna be 48.192x, and then derivative of 43.854 x cube is gonna be 131.562 x squared. Okay, x squared. Okay, now we have the derivative of this. What we're going to do, we're going to put, okay, they say wherever this is, they want f prime of 6. So the f of prime of 6 is going to be f into 6 equals to 7.46 plus 48.192. Remember, we said we're going to let change x equals to change in f, and then we're gonna let change square f equals to x squared, right? So here we're gonna put back our change in f. So it's gonna be change in f plus 131.36 to change square f. Okay, and then now we have the change in f and change in square f. We go back to our table. Remember, we are doing the forward difference. Our change in f is what? It's 5, and then our change in square f is what? It's minus 4. So wherever there's change in f, we're gonna put 5, and then wherever there's change in square f, we're gonna put negative 4. Okay, we were here, so it's gonna be 7.46 plus 48.192 multiplied by 5. The 5 is from the table. The coefficient of forward difference is the top one, plus 131.362 multiplied by negative 4. So the f prime of 6 equals to negative 277.828. Okay, so this is how we do activity 2.1 number 2. Okay, so the first thing, you construct your table. You'll be given the values of x and y, and then you gonna construct what? A table. You construct your table. After constructing your table, you gonna calculate the value of p. Okay, value of p. This is how we calculate the value of p. It's p is equals to x minus x0 over h. Okay, and then h, to calculate h, is b minus a over n minus 1. So all the time, most of the time, you have to check if you have the value of x or not. If you don't have, which means it was going to be x, it was going to be x minus 1. Okay, so wherever there's p, you're going to put x minus 1 over 0.6. So since we have the value of 6, we just substituted it. Okay, so after getting the value of p, you come into your formula here, and then you substitute the value of p, and then you calculate. After calculating here, we let change in f is equals to x, and then after that we substitute the values of x. We derivated because we want to estimate what? We wanted to estimate f prime of 6. Okay, so after estimating, we put back the change in f, and then we substitute the change in f, and then we get our answer. Okay, that's how we do forward difference. Okay, we have, okay, no, we're gonna do that later. So now let's do the backward difference. So we are done with the forward. With the forward, you just have to know the formula and where to stop. Okay, so now let's do the backward difference. Okay, we're still on activity 2.1, so we're gonna do number 3. We're gonna do number 3. Okay, so number 3, it says estimate f prime of 1, f into negative 1 and f of 6. So they want us to estimate this for the data in the table using backward interpolation. They want us to use what? A backward interpolation. So we're still gonna do the same. We're gonna construct a table. Okay, we're gonna construct a table. So we have the x values. We also have the f prime of x values. Okay, so on our x values, we have 0, 1, 2, 3, and then 4. Okay, and then on our y values, we have 1, 3, 13, 37, 81. Okay, so remember, all the time when we are doing the backward and forward and divided difference, we start by constructing a table. Okay, so let's construct a table together. So we have the x, we have the y. Our x value, it's 0, 1, 2, 3, and then 4. So guys, don't forget to skip a line when you construct a table, please. And then on the y, we have 1, 3, 13, 37, and 81. Okay, so remember, now we are doing the backward. We write our chain f facing down. So this is backward. It shows that we're doing what? A backward difference. Okay, so now let's calculate what's the value of backward difference here. The first value, guys, what's the first?
It's 2.
Okay, it's gonna be 2 here, and then 13 minus 3 is gonna be 10, and then 37 minus 13,
24.
And then 81 minus 37,
44.
yeah. Okay, and then now coming to the second one, it's going to be 10 minus 2, which is 8.
8.
Let me write. I skipped too much lines here. I want them to correspond. Sorry, so 10 is going to be here. Okay, so here it's going to be 8. And then 24 minus 10 is going to be 14.
14.
And then 44 minus 24 is going to be 20. Ne? Now moving forward, remember we said we stop when we have one value. And then for the third one, it's going to be 14 minus 8. 14 minus 8. 6.
6.
And then 20 minus 14. 6. And then the last one. Yeah, it's going to be 0. So you see, all the time it forms a pyramid. So now we are doing the backward, which means our coefficients is going to be 44, 20, 6, and 0. Okay, so these are the coefficients that we're going to use. It's for backward. For forward, we use the top one. And then for backward, we use the bottom one. Okay, moving forward, remember they want us to estimate, ne? And then we have the formula for backward. For forward different, it was negative, we were subtracting, and for backward we're going to be adding. Okay, so this is the formula for backward, is p into x, y. Where's the formula? Sorry. Is going to be yn. N is the last value, remember. Yn plus p, the backward one, f over 1 factorial, okay, plus p into p plus 1, backward squared f over 2 factorial, okay. So on the forward one, we were subtracting, okay? And then the backward one, we're going to be adding. Plus the p into p minus plus 1, p plus 2, and then it's going to be to the power of 3f over 3 factorial. So we're going to check where did we stop. We stopped at changing to the power of 4. So plus p into p plus 1, p plus 2, p plus 3, and then to the power of 4f over 4 factorial. Okay, like this. That's where we're gonna stop, because we stop at change to the power of 4f for the backward. So this is the formula for backward. For forward, we were subtracting, and then for backward, we're gonna be adding. It's p plus 1 plus 2 plus 3, and then for forward it was minus, and then for forward here it was y0, and then now here for backward it's yn. Okay, so we're gonna start by calculating h. Okay, our n. Okay, we're gonna start by writing the value of n. How many values of x do we have? 1, 2, 3, 4, 5. We have 5 values, so n is equals to what? Is equals to 5. And then after getting n, we're going to calculate h. H is b minus a over n minus 1. Okay, and then b is what is the last value of x, and a is the first value of x. So the last value of x is what? It's 4, and the first value of x is what? It's 0. So it's going to be 4 minus 0. It's going to be 4 minus 0 over n. N it's 5. 5 minus 1. Therefore, our h is going to be 4 minus 0 is 4. 5 minus 1 is 4. So h is equals to what? It's equals to 1. Okay. So now let's calculate p. P equals to x minus x0 over h. Right? Remember, they want us to estimate f into -1 and f is into 6. So now we have two values of x. Since we have two values of x, we won't substitute the value of x. If we had one, we were going to substitute the value of x. But since we have two, we are not going to substitute. We're just going to write x minus x0. Our x0 is what? Is the first value of what? Of... I think here I made a mistake when it comes to p. Let me check something. Oh, p is not, it's not x minus x0, it's x minus xn. Okay, sorry. So x0 is for forward and then xn is for backward. Okay, so here it's gonna be x minus xn. Xn is x5. So x5 is going to be 1, 2, 3, 4, 5. x5 is what? It's going to be 4. So it's going to be x minus 4 over 1. H, the value of h is what? It's 1. Therefore, p is equals to x minus 4. Remember, the reason why we're not substituting value of x here is because we have two values. It's because we have two values of x. Okay, so moving forward, we're going to just substitute the values of p into our equation and the value of yn into our equation. Okay, let's move forward. So we have the p of x equals to y. The last value is going to be y5, okay, plus p, the backward, over 1 factorial, plus p into p plus 1, and then squared f plus p over 2 factorial. So the value of y5, our y5 here is gonna be 1, 2, 3, 4, 5. It's gonna be 81. So wherever this where this y5, we're gonna write what? 81. So it's gonna be 81 plus the value of p. P is equals to x minus 4. So wherever there's p, we're gonna put x minus 4. Okay, so it's gonna be x minus 4, changing f. Okay, the backward one, changing f over 1 factorial. Okay, plus it's gonna be x minus 4 plus 1. Guys, are you following? We're just substituting here. Do you have any questions? Okay, plus the third one is gonna be x minus 4 plus 1, x minus 4 plus 2, then number 3 over 3 factorial. Remember, the change in f, changing this one, the backward, changing f, change to the power 4 f, it's 0. So it's gonna make everything to be equals to 0. Okay, this one, it's 0, right? You get it? So this one is gonna be 0. So when we multiply this equation by 0, it's gonna give us 0. We won't write it, so it's gonna be 0 here. Okay, after here we're gonna simplify. So we have 81 plus x minus 4, changing f, the backward one. So wherever there is the change in f backward one, we're gonna substitute with the coefficient of backward difference. So the first one is gonna be 44, the second one is gonna be 20, the third one is gonna be 6, and then the fourth one is 0. That's why I said the last quotient it's 0. So any number multiplied by 0 is 0. So the first coefficient for backward difference is 44, the second one 20, and then third one 6. Okay, so wherever there is this change in f, the backward one is gonna be 44. We're gonna substitute with 44, and then here we're gonna substitute with 20. Okay, and then here we're gonna substitute with 6. So let me just write it down this side. So we have the p of x equals to 81. Okay, plus x minus 4. Remember here we were multiplying with the backward change in f, so we're gonna write the coefficient of the backward difference, which was 44. So it's gonna be multiplied by 44 over 1 factorial, okay, plus the second one, it was the p into p plus 1, and then our p, it was x minus 4. So it's going to be x minus 4 into x minus 4 plus 1, and then multiply by the backward squared f. So which is what? Which is 20. The backward coefficient, it's the second one is what? Is 20. So we're going to multiply it by 20. We're going to multiply everything by 20. All over 2 factorial. Plus the third one is going to be x minus 4. X minus 4 plus 1. X minus 4 plus 2 multiply by the coefficient. The coefficient of backward cube f, it's what? It's 6. So it's going to be multiplied by 6, all divided by 3 factorial. So the fourth one is 0, because we're going to multiply by 0, and any number multiplied by 0 is 0. And then from here, we're going to simplify, guys, okay? So it's going to be 81 plus we simplify. So 44 multiplied by x, it's going to be 44x. Okay, 44x. Divided by 1 factorial, it's 1. Okay, and then 44 multiplied by negative 4. 44 multiplied by 4 is going to be 176 minus 176. Okay, plus, and then we simplify this. Okay, we're going to simplify, and then after simplifying, we're also going to simplify the third one. Okay, you guys, you're going to simplify, and then the final answer is going to be p of x equals to x cubed plus x squared plus 1. After simplifying everything, our answer is going to be x cubed plus x squared plus 1. Okay, and then remember they want us to estimate f into negative 1 and f into 6. Okay, so which means wherever this x, we're gonna substitute with negative 1 for the first one, and then the second one we're gonna substitute with x. Okay, with 6. So it's gonna be p into negative 1 equals to negative 1 cube plus negative 1 squared plus 1, and then you get your answer. Okay, and then p to the power, p into 6. Wherever there's x, we substitute with 6 squared plus 1, and then you get your answer. And then that's how the backward difference formula looks like. Okay, so we start by constructing a table first, and then after constructing a table, we write our formula, and then we substitute our values. Do you have any question under backward difference?
Yeah, can we please go back to, I think it's a third step. Yeah, here.
Oh, here.
Yeah, this one.
Yes.
So from here, we just multiply everything.
Yeah, but the coefficient of backward difference. So here we have 81 plus x minus 4 times 44. So here we're just simplifying. It's basic mathematics. You simplify. So it's going to be 44 multiplied by x, 44 multiplied by negative 4. And then you get 44x minus 176. And then when it comes to this side, you're going to have x minus 4 and then into x minus 4 plus 1. So here you have x minus 4 and minus 4 plus 1 is minus 3. So we're gonna have x minus 3, and then we simplify. Simplifying, and then x multiplied by x is gonna be x squared. X multiplied by minus 3 is gonna be minus 3x. Minus 4 multiplied by x is gonna be minus 4x. Minus 4 multiplied by negative 3 is gonna be positive 12. And then after simplifying this, you're gonna multiply it with 20 divided by what? By 2 factorial. Okay, and then you get your answer. So I didn't write it here. I said you guys, you can simplify everything. So after simplifying everything, our answer was x cubed plus x squared plus 1. Okay, and then they asked us to estimate f into negative 1 and f into 6. So you just substitute the value of negative 1 and 6. You get your answer.
Okay.
Yeah. Okay, Roche, are you good?
Yeah, I'm good.
Okay. So remember I said we have the backward and the forward, right? And the divided. So we're done with the backward and forward. Let's do divided different scheme. So on divided, let's say we have the value of x and y again, ne? And then our values. Sorry, just a moment. Okay, yeah, we have activity number 4. We're gonna do number 4. Okay, so number 4, it says deduce the divided difference polynomial from the scheme of the data given and then approximate f into 2. Okay, so let's do activity 2.1 number 4. Okay, so we have the value of x. We have the value of x, which is negative 1, 0, 0.0. Okay, is it? No, it's 0.5. Did you open textbook? 0.5, 1, and then 2.5. Okay, and then the y value, we have 3 minus 2 minus 0.375. And then we also have 3. The last one, we have 60.125. Okay. Now remember, every time when we're doing divided, forward, backward, we start by constructing a table. Okay, let's construct a table. So we have the x, we have the y. X, it's what? It's negative 1, and then 0, 0.5, okay, and then 1, and then 2.5, okay, and then y we have 3, negative 2, it's negative 0.375, and then we also have 3 and 16.125. okay, so this is what we have. Remember, on the divided, we had a delta. We were using a different formula. It was more like an S, so we're going to use delta F, the first one. Okay, delta F for the first one. What is the answer of the first delta? Hello?
It's going to be minus 5.
No. Oh, sorry.
Are we not?
Yeah. It's gonna be minus 5.
Okay.
No, that's incorrect. So when it comes to divided different scheme, we're going to divide. So it's gonna be negative 2 minus 3 divided by 0 minus 1. So it's gonna be y values divided by x values. Okay, so the first one is gonna be minus 3 minus 2, sorry. Yeah, I'm gonna write it down. So for f, is gonna be the first one. It's gonna be minus 2 minus 3 over 0 minus into minus 1. So we take y values and then we divide them with x values. For divided, remember we're doing divided difference, so we are dividing. So it's going to be y2 y1 minus y0 over x1 minus x0. So it's minus 2 minus 3 over 0 minus into minus 1. Do you get it?
Yeah.
Okay, so value is going to be minus 5 because minus 2 minus 3 it's minus 5, and then 0 into minus 1 minus 1 is going to be positive 1. So the answer here is going to be minus 5. Okay, and then for the second one is going to be
going to be, we divide y by x, ne?
Yeah, so it's going to be negative 0.375 minus into minus 2 over 0.5 minus 0. Okay, and then we get the answer. Are you calculating?
Yeah, I am.
Okay.
I got 3.25.
3.25. Okay, and then the third one is gonna be it's gonna be 3 minus into minus 0.375 over 1 minus 0.5. Are you following, Rochi?
Yes.
Okay, so it's gonna be 3 minus 0.0375 over 1 minus 0.5, and then the answer is gonna be 6.75. Okay, and then the last one is gonna be 16.125 minus 3 divided by 2.5 minus 1, and then we're gonna get 8.75. Okay, so we're done with the first derivative. Then let's come to the second one. It's gonna be delta squared f so to calculate the second one, we're going to say 3.25, okay, minus into minus 5, okay, divide by, okay, it's gonna be, we use x values, so it's gonna be 0.5 minus, we're gonna jump the 0, so it's gonna be 0.5 minus 1, so 0.5 minus into minus 1. Do you get it? So to do the second one, the delta square f, we skip one value of x, so it's 0.5 minus 1. Are you following?
Yeah, I think I see.
So we're gonna skip one value of x. When we're calculating the second column, the delta square f, we're gonna skip one value of x. So it's gonna be 3.25 minus into minus 5 over 0.5 minus into minus 1. Okay, and then we're gonna get it as 5.5. Okay, and then the second one, we're gonna say 6.75. Okay, 6.75 minus 3.25. 6.75 minus 3.25 over, remember, we're gonna skip one value of x, so it's gonna be 1 minus 0. Okay, and then we get the answer. Remember we're doing here, it's 0. No, it's not 0. 3.5.
No, I was saying that
Oh,
3.5, yes. I was
yes.
just saying that.
Oh, minus
since
0.
0.5, yeah.
Oh, okay. So we're gonna get 3.5. And then the last one, we're gonna say 8.75 minus 8.75 minus 6.75 over, we're gonna skip this value. Okay, so it's gonna be 2.5 minus 0.5. And then we get the answer as what? As 1. So we're done with the second one. Okay, and then now let's go to the third one. So it's going to be delta cube f. Okay, so to calculate the delta cube f,
Professor, can you show me how you got the delta squared f on the last one?
On the last one, okay. The delta square is going to be number 3f. So it's going to be 8.75 minus 6.75 ne? Over, remember we skip one value. Okay, we're going to skip one value, so it's going to be 2.5 minus 0.5. We skip one, yeah. And then you're going to get the value 1. Ne?
Yeah.
Okay. So now going to the cube, the third one, so it's going to be delta cube f. So to calculate the cube one, it's going to be 3.5 minus 5.5, okay, divide by. So the third one, we're going to skip 2 values of x, okay. We're going to skip 2 values of x, so we're going to skip these 2. We're going to skip these 2, so it's going to be 1 minus into minus 1. Okay, guys, so for the square one, we skip 1 value. For the cube one, we skip 2 values, okay? And then we're going to get answer as -1. So we have -1 here. And then for the second one, we're gonna say here we got answer as -1. Ne? And then we're gonna say for the second one, we're gonna say 1 minus 3.5 over, remember we said we skip 2 values of x, so we're gonna skip this one and this one, so it's gonna be 2.5 minus 0. Okay, and then we get our answer as what? As -1. So we have -1. And then the last one, because it's going to be this 2, it's going to be delta to the power 4f. Okay, and then to calculate that, this is how we do it. Oh my goodness, sorry. So it's going to be -1 minus into -1, okay, divide by. So on the last one, remember on the cube one, we skip 2 values, and then now we're going to skip 3. So it's going to be 1, 2, 3. So it's going to be 2.5 minus into -1. And then -1 plus 1 is 0. So the answer here is going to be 0. So it's going to be our last value. So the divided one, it's confusing a little bit because we're going to divide two variables, the y and x. So it's y value divided by x value. And then for the second one, we skip one value of x, and then the third one we skip 2, and then the third one we skip 3 values of x. Okay, guys, did you get this? The divided difference.
I got it, just that it's complicated.
Yeah,
but
and
it's
very long. Okay, and then now we're going to have formula for divided. Remember, you have to cram these formulas because they are not provided. Yeah, I will summarize everything and then you'll see which formulas you have to know. Okay, sharp. So now let's write divided formula. It's f into x equals to y0, okay, plus delta 1 f of x into x minus x0. So we stop where we stop on our table. Okay, so on our table we stop at to the power of 4, which means we're gonna write our formula up to 4. Okay, so this is the first one, plus delta 2 f of x into x minus x0, x minus x1, okay, plus delta 3 f of x into x minus x0, x minus x1, x minus x2. Okay, so this is the third one, and then the fourth one is gonna be delta 4f of x into x minus x0, x minus x1, x minus x2, and then x minus x3. Okay, this is 2 here. Okay, so this is the formula. Remember, we stopped at delta 4, and then when we write our formula, we're also gonna stop at delta 4. Okay, so we have f of x, and then now we're going to substitute. Okay, our y0. Y0 is what? It's 3. Our y0 is what? It's 3. And then delta f1, this is 1, this is 2, this is 3, and then this is 4. And then here, we use these coefficients, okay? We use this coefficient. So the delta 1 is going to be negative 5, delta 2 is going to be 5.5, delta 3 is going to be negative 1, and then delta 4 is going to be 0. Okay, so divided, we use the top one. Backward, we use the bottom one. Forward and divided, we use top coefficients. Okay, and now our y0, it's 3. Okay, and then our delta 1, it's negative 5. Okay, so it's going to be a negative 5 into x minus x0. Our x0 is what? It's negative 1. Our x0 is what? Is negative 1. So it's going to be minus into negative 1. Okay? Plus delta 2. Our delta 2 is 5.5. Okay? Delta 2, it's 5.5. Into x minus into minus 1 because it's x0. Okay? And then multiply by x minus x1. x1, it's 0, so it's going to be minus 0. Okay, and then plus delta 3. Delta 3, it's negative 1, so it's going to be plus negative 1. Negative 1 into x minus x0. x0, it's negative 1, and then into x minus x1, x1 it's 0, and then into x minus x2, x2 is minus is 0.5, so it's going to be x minus 0.5. okay, and then plus x4. Our delta 4 it's 0, so 0 multiplied by this is going to be 0, so it's going to be plus 0, and then after here we're going to simplify. Okay, so it's going to be 3 plus negative 5 multiplied by x, and then it's going to be negative 5. Negative 5 plus times negative into negative 1 is going to be a negative 5. Yeah. So here you just simplify. Okay, we're going to multiply this negative 5 with x, multiply negative 5 with negative 1, 5.5 multiplied by x, so you simplify everything. So after simplifying, your f of x is going to be equals to a negative x cube, okay, plus 6x squared minus 6x plus 4. Okay, and then from our quotient they want us to estimate f of 2. So wherever there's x, you're gonna put 2. So it's gonna be f of 2 equals to a negative 2 cube plus 6 into negative 2 squared minus 6 into I'm lying, it's not negative 2, it's positive 2. So here I put, okay, let me just erase everything. So wherever there's x, we're going to put 2. So it's going to be negative into 2 cube. Right, is plus 6 into 2 squared minus 6 into 2 plus 4. And then you get your answer as 8. So this is how divided different works. Okay, so here you just divide the value of y with x, and then when it comes to the second one, you skip. Rochi, do you have a question? Hello, guys, do you have any question?
No, I don't have.
Okay, sharp. So for now on unit 2, we're gonna stop on divided. Okay, there's this, where's my email? It's here. There's this question paper that Rochi shared with me. We're gonna do number 1 and number 2 if we still have time. Okay, so this is 2024 test 1. Okay, so this is how they ask questions. They say number 1.1, the head loss H in a pipeline is described by H equals to 0.5 LV squared over 2 GD. Rochi, did you try to solve this question?
No, I haven't.
Okay, so we're gonna do 1.1 and 1.2, also 2.1. Okay, so 1.1, we have H is equals to 0.5 LV squared over 2 GD, where L is equals to 20 meter is the length of the pipe, V 15 meter per second is the mean velocity of the fluid, D is equals to 8 meter is the diameter of the pipe, and G is acceleration due to gravity, 9.8. Okay, if errors in measuring LVD were captured as 0.001 blah 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 respectively, and then they say we have to determine the absolute error in measuring H, okay, and the relative percentage error due to D. Okay, so now we have the H. Okay, we have H equals to 0.5 L V squared over 2 GD, and then we're given the length is equals to 20, V is equals to 15, okay, and then D is equals to 8. and then G is equals to 9.8, and then we're also given the change in L as 0.0001, change in V as 0.0015, and change in D as 0.01. So I want you guys to give me the formula for this, the absolute error of H. How are we going to write the absolute error formula for H? Remember, our variable is what? It's HLVD. We have 4 variables, okay? HLVD. How are we going to write the absolute error equation? So we have we're gonna have the change in H equals to we have 4 variables. We have HLVD. How are we going to write our absolute error equation?
I'm gonna say partial derivative of H divided by partial derivative of L.
Yes.
Plus partial derivative of H divided by partial derivative of V.
Yes.
Plus partial derivative of H divided by partial derivative of G.
No.
D of D.
No. G is not our variable. Remember, our variable is HLVD. We know G is gravity. It's 9.8. Like we have the value. It's given all the time. So we're going to use the variables only. It's LVDH. So here's gonna be D. Okay, multiplied by changing D. Okay. That's how we're going to write our equation. And then after here, we're going to derivate. The partial derivative of H with respect to L. What is the derivative of H with respect to L?
Okay.
Bongani, are you still here? Bongani?
Yeah, I'm still here.
Okay,
Yeah,
can
I'm
you
still
please derivate H with respect to L?
H with okay.
Okay, derivative of L, it's 1. Derivative of L is going to be 1. So we're going to be left with 0.5 V squared over 2GD. Okay, multiplied by changing L. Plus, here we're going to derivate V. So it's going to be derivative of V squared is going to be 2V. Okay.
So that 0.5, we write it as it is.
Yes, it's not a variable, it's a value.
Okay. So for V, we're going to get 0.5 L2V.
Yes. Yes. And then how are we going to derivate D? What is the partial derivative of H with respect to D?
The partial derivative of D, we're not going to get 1 there.
No, it's on the denominator. How are we going to get 1?
Derivative of D is 1. So we'll be left with 2g.
Are you saying what will be the derivative of h with, derivative of h with respect to d? Just give me the final answer. Okay, it's fine. Remember, during the week, we took whatever that on the denominator to numerator. So we can write our h as 0.5 LV squared times 2 to the power of negative 1, g to the power of minus 1, d to the power of minus 1. And now here we're going to focus on d only, right? So which means it's going to be derivative of d to the power of negative 1. It's going to be negative d to the power of negative 1, negative 1. So therefore it's going to be negative d to the power of negative 2, right?
Yes.
Roji? Okay. So now we're going to have 0.5 LV squared times 2 to the power of 1 g to the power of minus 1 times a negative d to the power of minus 2. So we derivated d to the power of minus 1 and then we get negative d to the power of minus 2. Okay, so 2 to the power of minus 1 is the same as 1 over 2, and then g to the power of negative 1 is the same as 1 over g, and then d to the power of negative 2 is the same as 1 over d squared. Okay, so what we're going to do here, we're just going to write our equation. So it's going to be 0.5 LV squared multiplied by 1 over 2, it's this one, okay, multiplied by 1 over g, it's g to the power of negative 1, multiplied by negative 1 over d squared. Okay, so therefore the partial derivative of h with respect to g is going to be 0.5. It's going to be 0.5 L V squared, okay, over, actually this negative here is going to be a negative 0.5 LV squared over 2g d squared. Okay, do you have any question here?
No.
Okay, so this is how we derivate it. Remember, remember I said we have different types of rules, derivative rules. We have different types of derivative rules. We have product, chain, power, sum, difference, quotient. You still remember that?
Yes.
So we're gonna apply those rules here all the time. We are going to apply them here. Okay?
Okay.
Yeah. So our change in h is going to be equals to 0.5, what? 0.5 v squared over 2gd. Okay? Change in L. Okay? Plus, are we done? We're not done, right? We were doing what? Oh, okay, yeah. Plus this, plus 0.5 LV, plus 0.5 L times 2V over 2GD multiplied by change in V. Okay, plus this is 0.5. Okay, plus the partial derivative of h with respect to d, which is going to be negative 0.5 LV squared over 2g d squared multiplied by changing d. So this is how our absolute error is gonna look like. Okay, and then you substitute the value. Remember we are given that L is equals to 20.
before you go forward.
Yeah.
Can't we cram this one? The derivative. The more you start these cards, it will eat our time to derivate this d. So now if we have one variable like this, just like when we had only d, right?
Yes.
All we should know is that after derivating, it will come back as negative to the first value.
Yes.
And then our actual, it should be d squared or a squared, whichever number they will give us.
Yeah, you can do that. Let's say our d here, it was d to the power of 3, which means it was going to be a negative d to the power of negative 4, right? So at the bottom you're going to write what? D to the power of 4, and then here you're going to write what? A negative. With remember, we have 4 here, we have 3, so it was gonna be a negative 3. Sorry, so here it's gonna be a negative 3, and then at the bottom you're gonna write d to the power of 4. Yeah, you can cram, you can do that.
Yeah, I see.
You can do that. So it's gonna be depending on the power of d. So if d is to the power of 1, it's going to be a negative d to the power of squared. Okay, and if it's to the power of 3, it's going to be a negative 3 on the numerator, and then on the denominator it's going to be d to the power of 4. Yeah, you can do that, yes. So from here, you're going to substitute your values, and then you get your answer of changing h. And then because L it was 20, and then V it was 15, and then D it was 8, G it was 9.8. What else? We also have changing L, changing V, and changing D. You just substitute and get what? The absolute error of H. Okay? We were doing this test 1. This is what we were doing. They want us to determine what? The absolute error in measuring what? H. Okay? And then they also want us to determine relative percentage error due to D. Remember when we started, I showed you the formula for percentage error. Do you guys still remember? The percentage, the relative percentage error formula. Do you still remember that formula?
I think so.
Okay, so remember I said on the error we have relative error. Relative error, it was R equals to the absolute, let's say X over XA, okay? And then the percentage error, it's what? It's it was 100, right?
100
multiplied by R. So here they want us to what? To determine what? The relative percentage error. Relative percentage error. So you're just gonna multiply this by 100. It's the same thing. So here we have the change in H, and they want us to determine what? The relative percentage error due to D. So what you're going to do here, it's this. They want the percentage, relative percentage error, PR. So here the PR is going to be changing H over D, okay, multiplied by 100, because they say with what? Due to D, the relative percentage error due to D. So to calculate that, it's changing is absolute error of H over D times 100. Remember, we have the value of D, we're gonna calculate the value of H. You're just gonna substitute, and then you get the percentage error. Do you have any question here? Rocha, are you still here? Okay. Yeah, our class is long. We're gonna cut it in few minutes. I just wanna show you something in 1.2, and then we're gonna end our session. 1.2, they say the calculation of mass of an entity W is based on quantities R and Q. You see here we have variable W, Q, and R. Okay, defined by the equation W's arcsine square root of R over Q. If the weights are found to be R equals to this, Q equals to that, and if allowable error deviation from weight from weight quantities R and Q are to be at most 1% and 2%. So you see here the absolute error, we are given them in percentage. You see that it's 1%, 2% respectively. And then they want us to determine the maximum error in the calculation of W. Okay, so this is how we're going to solve it. This is 1.2. We are given that W is equals to inverse sine square root of R over Q. Okay, and then we're also given R as 0.21 G, and then Q as 0.32 G. Okay, and then also we are given that change in R, it's equals to 1%. Okay, no, let me not just write that. And then change in Q, they say equals to 2%. Okay, so when we are given the absolute error in percentage, this is what we do. We multiply percentage with the value of R. So therefore our change in R here is gonna be 1% multiplied by R. Okay, then here it's gonna be change in Q equals to 2% multiplied by Q. So every time when you are given your absolute error in percentage, you multiply it with the value of R or Q with that value. Okay, did you get it?
Yeah, I got it.
Yes, so from here you're just gonna write your absolute error, which is gonna be the partial derivative of W over partial derivative of R plus change in R plus the partial derivative of Q over partial derivative of R, okay, plus the partial derivative plus the partial derivative of W over partial derivative of Q times change in Q. So this is how you're gonna write your equation, and you derivate W and R, derivate W with respect to Q. Okay, so we're gonna continue. I think we're gonna continue on Monday, and then we're gonna do this what do you call test 1.2, and then we're gonna continue and show you how we're going to derivate arcsine square root of R over Q. Okay, and then the one that Rochi asked me to help her with, I'll send it on the WhatsApp group, and then you're gonna ask questions there. Okay, no problem. Do you have any question here?
No, my mind is tired.
Yeah, let's end this session, then we're gonna continue on Monday.
Okay, thank you.
So you guys, you got
from now on, I'll be practicing minutes. I'm done writing for that training.
Okay, yeah. Don't you should also practice forward, backward, and divided, ne? Because it's there. You see on 2.1, they say construct a finite difference scheme for the data in the table and show the difference between the forward difference scheme and the backward difference scheme by highlighting the coefficient for each scheme. You see, so I think you should also do 2.1, and then you're gonna ask me if we get the same answer or not.
Okay, for this one I can do. I think it's simple.
It's simple, right?
The only one that's challenging a little bit, the divided one.
Yeah.
But I will do it.
Okay, no problem.
Sure.